Thanks everyone for joining us today. Good morning to those of you on the other side of the ocean. It's the afternoon where I am at. Thanks for making the time to come to this session today. We're going to be going over basic wastewater math, and it's going to be targeted for wastewater operators. And so you all haven't met me yet. I'm Shannon Sloan Pepper. I'm a water utility trainer and specialist. I work at the Southwest Environmental Finance Center. My email's there on the screen, and I'm going to show that again at the end in case you want to get back in touch with me with any questions that you might have. So the Southwest EFC, as you all probably know, this is the third session in this series. We're part of the UNM School of Engineering, so the University of New Mexico School of Engineering. And this training series is funded by the US EPA. We're housed in Albuquerque, New Mexico. So this also is probably a review for you all. Just a quick slide about meeting controls. You've got that control bar for your Zoom meeting. That's either in the top part of your screen or the bottom part of your screen. There's a mute and unmute button. And I'm gonna ask for the most part, it's to stay muted, but if you all are all of you all who are in a big room together, I think that'll be totally fine to leave your sound off. That way you can jump in whenever you want to and don't have to futz with the meeting controls. So don't worry about muting yourself for this one. There's a start and stop video in that bottom bar too. And then also there's that chat icon. And make sure that you utilize that chat. There'll be a couple questions where I'll ask you to use it. And you can also use it to put in questions as I go along. Valeria will be monitoring that and can shoot those questions to me if you have any as we go. So this training series is really just meant to meet the basic requirements, the need to know criteria for wastewater treatment operator class 1 and class 2 exams. So that's what we'll be kind of focusing on for this series. Today we're covering basic math. In the next class, we're going to get a little bit more in depth. We might in this series cover a little bit more into the more advanced levels, but we're really shooting for those base levels with this one. Here's our schedule for 2025. We're on the third episode in the series. As you can see, we've got a bunch more lined up. I think there's 26 total, and we're looking forward to doing these with you continually, bi-weekly, the rest of the year. Just a little reminder, we have this webpage for the training series. So if you want to get on there and look at the schedule yourself, check out the trainings, check out webinar recordings, that will all be there for you at this webpage on the screen here. And also just a reminder to everyone to please sign up for every single session individually to make sure that you get credit for these trainings. And whoever is facilitating the meetings at your location should have a sign-in sheet, and that will just require you to get on there and sign in individually so that you get those credits. So we're here today to talk about basic math, right? Why is it important for wastewater operators to have a good understanding of math? Math is really in everything that we do as operators. It's involved in storage capacity and flow and water detention rates. It's used to determine surface loading of various parts of the system, also to calculate chemical usage and proper dosage, biochemical oxygen band, and then also the managerial side of things, rate setting and budgeting. So all of these are possible with math, but we need to really have a base understanding of some core math concepts, the fundamentals of math, we could say. So today's math topics are, we're going to go over equations, so just basics, order of operations, how do you kind of approach an equation, and then we're also going to look at how do you rearrange those equations and solve for the unknowns, which is also known as algebra. We're going to also look at percentages, and units and conversions, so conversions from fractions to percentages, and conversions between different types of units that we'll be using in these math equations. So that's all we're covering for today. We've only got an hour, and we'll have a couple of practice problems thrown in here as well. If you all wouldn't mind locating a pen and paper, we are going to be doing a little bit of practice with equations and calculations. So if you've got a pen and paper around, that's going to be really helpful. Even if you feel really solid and comfortable with math, it's really good to practice these things and just make sure that you've got a good understanding of the core concepts. So grab a paper, grab a pencil. It's also helpful to have like a calculator of some kind. You can use your phone if you have a smartphone as a calculator, or sometimes dumb phones have calculators as well. And then, for the test that you'll take for an exam, operator exam, you'll be often given calculators to use. So calculators are helpful. If you don't have one for today, we're doing pretty basic math, but you will want one for the next math class in the series for sure. So come prepared with that if you can. So at this point, I'm just really curious if you have access to the chat. I know some of you are four to a room, so it's kind of hard. Maybe what you can do is hold up your fingers for me so that I can at least see you. But would you say on a scale of 1 to 5, what's your comfort level with math and proficiency with math? Are you like 1 is like this little kid in the corner trying to count on their fingers? You're feeling pretty like you've like kind of still at the basics, or are you feeling really comfortable and proficient, like comfortable doing calculus or whatever? Um, would you mind dropping that number in the chat if you're by yourself, or just holding it up with your hands if you're in the room there? Cool. Yeah. Nice. Nice, nice, nice. Okay. Thanks, guys. That's just really helpful for me to get a sense for who's in the room today and where I should focus my attention here. Cool. 8 to 9. Nice. Thank you. Appreciate that. Okay. Great. Well, today we're going to cover the fundamentals, and hopefully by the end of today, you'll feel at least like you have a little refresher on some of these really basic concepts. And also, I just want to say that I'm going to kind of blow through stuff pretty quickly today. But if you need more practice or more help with anything that we talk about today, please reach out to me and I can send you more resources, more practice problems, whatever you might need to kind of work on those aspects a little more, because all of it's pretty, math is big and important. So got to make sure you got the fundamentals down. So first of all, what's an equation? That's kind of what we're focusing on for the first part of this webinar today. Equation is really just a technique for answering a question that you want to solve, that you want to find the answer to. So that question could be how much of something, or how long does something take, or how fast does it move? These types of questions. And when I started taking math, somebody once told me that math is really a language. And so you're using numbers as kind of symbols, the way that you use words as symbols to stand in for meanings of things. And if we think about math as a language, then a math equation is really like a sentence, a balanced math sentence. So everything on one side of the equation, if there's an equal sign, is going to be equal to everything on the other side of the equation. And so everything that we do with math basically involves, or most things that we'll do with math in these courses will involve an equation. So we'll dive into that. But first, let's talk about order of operation. So in a math equation, everything kind of has to happen in a certain order, right? You may or may not have heard this acronym PEMDAS, which has got a little rhyme or a little phrase to remember it. It's please excuse my dear Aunt Sally. And that just refers to the order that you want to always do everything in an equation when you're solving. So you start with things in the parentheses. So anything that's in a couple parentheses, you do that first. That's the number one. Then we'll move to E, exponents. And exponents are those little numbers that are like up in the top right kind of corner of the number. And we'll kind of go over what exponents are in a little bit here. Then there's multiplication, division. So that's the multiplication and division part of the equation can happen at the same time. And if there's not one, then you just do the other. And then you move on to addition and subtraction. So let's look at what that kind of looks like in practice here. Here's an example that we can work with. So we've got 4 times 2 plus, in parentheses, 6 times 5 squared. So that's that exponent that I talked about. It's that little guy in the middle, or little guy in the upper right-hand corner, minus 16. So then what do we get? How do we kind of approach this equation? So if we're going in order, please excuse my dear Aunt Sally, we're going to start with the P. So we're going to do the parentheses first. Inside of the parentheses, we've got 6 times 5, which is 30. So kind of put that 30 in those parentheses. Okay. Then we're going to move on to the next part of the equation, the exponent. So that's that tiny 2 up above the 30. And all that means is that when you have the number there, we call it squared or to the second power. It just means that you multiply that number by the number of times that the number is, right? So 30 times 30, 32 times. If it was a 3, we would go 30 times 30 times 30, and so on. And if you have, depending on what your calculator is set for, if you have a really basic calculator, you might just have to go 30 times 30 times 30. In this case, it's just squared, so we can just do it twice. If you have an algebraic calculator, you can go, usually there's a way to put in a little exponent there. But we'll solve that next. So 30 times 30 is 900. Okay, so now we're going to move on to the multiplication and division. So multiplication, we've got 4 times 2. That's going to be 8. Okay, and then we don't have any division in this equation, so we can just move on to the next step. We've got addition and subtraction. So at this point, all we have to do is plug these numbers into our calculator. You can also do it in your head, and that's going to give us 892. So if you approach this equation in a different order than what we went over, you might get a different answer. So it's really important to remember the PEMDAS. Please excuse my dear Aunt Sally for your order of operations in all equations. So if we're thinking about equations as balanced math sentences, right? Left side equals right side, we can also think about rearranging them, which makes those equations easier to handle before we start plugging in our known numbers, and it also helps us keep track of the units that we're solving for in our equations. So let's look at how we might rearrange math sentences. This is also known as algebra, solving for an unknown. So the unknown is basically just the part of the equation that we're trying to figure out. We're trying to solve for it. It's sometimes represented by a letter that you might see, like D or T or X or some other, call them variables. It's just a letter that's standing in for the unknown number. And when you're solving for that unknown, the variable or unknown has to be by itself on one side of the equation, or that makes it a lot easier to deal with when you're going through and making your calculations. So in this case, the equation that you see at the bottom of the screen here is 46 plus x equals 98. X is that unknown. We want to know what that is, but how do we get that unknown by itself so that we can figure out what it is, what it equals?
Oh,
So in order to solve for x, we're going to have to get it alone. So we're going to have to isolate it on one side of our equation. So to do that, we have to move other numbers across the equal sign. And the way that works, because equations have to be balanced, they have to stay equal to each other on both sides. When one number crosses the equal sign, basically it just does the opposite of whatever it was doing on that side of the equation on the other side of the equation. If a number is positive on one side of the equation, then it's going to be subtracted from both sides. And if a number was negative from one side and you're trying to move it to the other, then it's going to be added to both sides. So an example of that is on the right here. We've got 46 plus x equals 98. So in order to get that x by itself, we're going to subtract 46 from both sides of the equation. Because you see 46 plus x, we just want to get that x all by itself, and that's going to help us figure out what it is. So we're going to subtract 46 from 46, which gives us 0. So we cancel it out basically. And then we're left with x equals 98 minus 46 on the other side. And that's a pretty easy calculation. If we do that, plug that into the calculator, we get x equals 52. So we know that our x is 52. Another example of that, let's look at if you're trying to move a number that's being subtracted, what we're going to do in this case, x minus 12 equals 25. We want to figure out what x is. We're going to just scoot that 12 over to the other side by adding it to both sides of the equation, because right here it has a negative sign in front of it. It's being subtracted. So remember, if we want to move it over, we've got to do the opposite, add it to both sides. And so minus 12 plus 12, those cancel out. we were left with x by itself equals 25 plus 12, and 25 plus 12 is 37. So that's just a little bit, that's kind of the bare basics of rearranging your equations with addition and subtraction. Let's look at multiplication and division next. But first, I would like everyone to take a moment to practice solving for the x. So go ahead and grab your scratch paper and your pen. Or you could potentially do it on your phone if you don't have a pen. But really having the paper is the best. So if you've got that, grab it.
You guys got me.
And for you all who don't have a pen and paper with you today, I'd recommend if you have a chance going back to the recording and just like working through these problems yourself, just because it's like super hard to learn and solidify like math concepts if you're not doing them yourself. So one thing to understand the concept and then applying it can sometimes be really tricky. So I recommend going back and doing that later. I'll give everyone, see, another minute or so to work on these two equations. And feel free to talk to each other too if you've got more than one of you in a room. Go ahead and work through the problem together. It's totally fine to do that and pretty great actually, because I can't be in the room with you, so you all have to help each other out. Okay, so how are we doing on those equations? I'm going to go ahead and work through these to kind of show you how I might approach this. There's often more than one way to do this, so this is just one way. So we're going to solve for x. Let's start with the one on the left side. 2 plus 15 minus 8 plus x equals 50 plus 8. So basically, to get the x alone, we're just going to shift this whole phrase or these three numbers on the x side of the equation over to the other side. And because this is just addition and subtraction, we're basically just going to do the opposite on the other side, right? So 2 plus 15 minus 8 is going to turn into, we have the 50 plus 8 already on the right side, and now we've added minus 2 minus 15 plus 8. So that sign got changed. And now all you got to do is plug that into your calculator, and you're going to should get an answer of 49. And so that's our first x. Let's look at the second one. So if we solve for x, we've got a lot going on here. We've got to move all of these phrases around the x to the other side of the equation. So here, this is kind of interesting. So we have a negative sign in front of the x. So when we move all those numbers away from the x, we're switching their signs. So we start with 29, minus 8, minus 6, and then minus 5 and minus 2, because all of those numbers are positive on the left side. But now we have a negative x. So what are we going to do about that? Negative x, if we do the subtraction, we have that. But what it basically is that we can just multiply both sides by -1, which is going to land us with a positive x, but then a negative 8. So it's just kind of that thing where it's like, if you do it on one side, you have to do it to the other. And that's how you keep those equations balanced. That one's a little complex because it's involving the negative, but let me know if you have any questions about that one. And we're going to move on here. So that's addition and subtraction. Okay. So now let's look at multiplication and division. So if we're trying to get x alone and there's multiplication and division involved, again, the numbers just have to be balanced on both sides. So when the number crosses the equal sign, it does the opposite of what it was doing on the other side of the equation. So if a number is multiplied on one side, it's going to be divided from both sides of the equation. If a number is divided on one side, we're going to multiply it by both sides. And that's just to get that x by itself. So in this case, in this example, we have a 5x equals 55. So we want to get that x by itself. 5 is being multiplied to x. So we're going to have to divide both sides of the equation by 5 to get that x alone. So if we do that, we get to cancel the 5s on the side on one side of the equation because 5 divided by 5 just equals 1. And 1 times x is just going to be whatever x is. So we've basically gotten rid of that the number in front of the x on that side, but then we have to divide 55 by 5. So if we do that, we're left with x equals 11 because 11 times 5 is 55, right? So there's an example of that for multiplication and division. Now we're going to do another practice. So grab that pen and that paper, and we're going to practice solving for x using multiplication. So for this equation, we've got x divided by 8.34 times 5 equals 15. So that's the equation we're starting with. Try to get x by itself so that then we can solve for x and figure out what it is. So I'll give everyone about a minute to do that one.
It's hard to follow along when you don't come prepared.
Sorry, did somebody say it was hard to follow along?
No, sorry, GWA, I'm talking to, it's Mary Ann here, talking to our folks here.
Oh, got you. Okay, so let's look at this one. So if we're trying to solve for x, remember our PEMDAS too. So we've got division and multiplication here. I usually find it easiest if we have a little, like we have on the bottom of the x here, 8.34 times 5. I like to do that one first. That makes it a little easier to work with. So if we do 8.34 times 5 and plug that into the calculator, you're going to get 41.7. So now we're left with x divided by 41.7 equals 15. So to get that x by itself, because we're dividing here, we're going to have to multiply 41.7 on both sides. So we're just doing the opposite, basically, the opposite in the equation language. So if we multiply 41.7 by both sides, that 41.7 cancels out under the x, where we get x by itself. And then we multiply 15 by 41.7, put that into the calculator, and you get 625.5. Okay. Let's do one more. Let's look at solving for x once again. This equation, we've got x times 7.2 times 8.34 equals 2,550. So go ahead and see if you can get x by itself again. This time we're starting with the multiplication, so it's going to be a little different.
41.7 simplified.
So keep the distance 16.3 x and then what did you get, Brett?
Okay, 41.7.
Okay, let's check it out. Let's see what we got here. So if we're solving for x, so we've got these two numbers here, 7.2 and 8.34, that we're multiplying together. I like to just do that first, just to make them one number and make them easier to work with. So if we do that, we're going to have x, we multiply 7.2 times 8.34, then we're going to get 60.048. And so now we just got to get that x by itself. So we're going to divide, because we're multiplying here, x times 60.048. We're going to divide that on both sides of the equation to get that x alone. So if we do that, it cancels on the x side. And then if we go 2,550 divided by 60.048, we should get x equals 42.47. How are we doing? Okay, cool. Yeah, this is the kind of thing where like you could really, if you're having a hard time with it, you could really practice this and practice those going through and getting that x by itself. It's kind of a fun puzzle if you're into puzzles. And it's a really good thing to practice because the equations that you'll see on wastewater operator exams are generally pretty they can be as basic as this, but they can also be a lot more complex. So it's good to feel really comfortable here. Just getting that X alone and moving stuff around. On your ABC exams, you'll have a formula sheet. And I can actually drop that in the chat at the end of the conversation here. You don't have to worry about taking a picture of it. I have a good PDF that I can drop in the chat and you guys can have it. I don't know if you have it already or not. But this formula and conversion table will be available to you when you take your exams. And it's got all sorts of it's got just a glossary of good formulas. And any of these formulas you can take and you can rearrange in the same way that we just did with those equations. So if you're trying to solve for an unknown, take this area of a rectangle equation. If you know the area of the rectangle and the length, but you want to find the width, you can use that same concept to get the width by itself on one side of the equation. So that x variable is just, it can be anything. It's whatever your unknown is. So you can also play around with that if you want by yourself. If you also want more algebra practice and prep for your test, you can practice just rearranging the equations that you see here. You don't need numbers to work with them. You can just work with the variables themselves and see if you can mix and match those equations to get those unknowns by themselves. So we've got all sorts of equations. They're listed in alphabetical order based on the thing that you probably want to be looking for. And then there's also this kind of neat strategy at the end called pie wheels. I haven't worked with them very much, but I know how they work, and some people really like them and find them to like make a little more sense than the equations that you write out. I don't have time to go over them today, but if you're curious about them, want to practice with them, there's some really good videos online that you can just like look up on YouTube. Also, I'm totally happy to explain how they work if you're curious about them. But those pie wheels are also available on your formula sheet for your exams. Okay, let's look at fractions and decimals. So these come up a whole bunch. They're basically just used to represent parts of a whole. So a number without a fraction is what we call, or a decimal is what we call a whole number. And then a fraction or a decimal is just like a portion of that whole number of one, basically. And often we'll have to convert between fractions and decimals depending on what we're doing with our equation and what kind of answer we're trying to end up with. So you might need to convert between those fractions and those decimals. It's just two ways of writing the same thing, basically. So because a fraction is a fraction of one, and so is a decimal, to go from a fraction to a decimal, all we're doing is dividing the numerator over the denominator. So the numerator is the top number and the denominator is the bottom number. So if we're looking at a fraction of 1/2 or 1/2, basically to get that into a decimal, all we have to do is go 1 divided by 2. You could just put that into your calculator and what's going to come out is 0.5. So same thing, 0.5 is the same as 1/2 or 1/2, right? And then if you want to go from a decimal to a fraction, then you'll write the decimal, to write the decimal as a fraction, you'll multiply
or if you
numerator and denominator both by 100, and then simplify using the lowest common denominator. So what that means is if you're starting with 2.75 and you want that to be a fraction rather than a decimal, what you're going to do is multiply 100 by 2.75 and then divide that by 1 times, because 2.75 is just another way of saying 2.75 you can go divided by 1. That's the fraction that you're that you're starting with here. So 1 times 100, 2.75 times 100 over 1 times 100. And so if we look at that, then we have 275 over 100. And so if we want to turn that into a fraction, we want to simplify it down. So 275 over 100 is kind of an unwieldy and huge fraction. And we can simplify it by finding the lowest common denominator. In this case, that's going to be 25. So we can go 275 divided by 25 and 100 divided by 25. That leaves us with 11 over 4 as our final fraction. That one's a little more complicated. I would say that you're more likely to encounter a situation in which you're trying to convert a fraction to a decimal than a decimal to a fraction. But just so you know, and for your information, that's how you might go about doing that if you really wanted to have that fraction or have that decimal represented as a fraction. So one way to think about percentage is that it's just another fraction. It's yet another way to represent a fraction. A percentage is percent, which also just is another way of saying parts per hundred. So these are all fractions with 100 in the denominator, or the lowest part of the fraction. And those can be converted to either a fraction or a decimal. So if we start with 30%, 30%, so 30 over 100 is how we would find that. And so that's one way of writing that fraction, and you could simplify that down too. But that's also the same as writing 0.3. So if you put 30 divided by 100 into your calculator, you'll get 0.3. And that's also kind of a helpful thing. Sometimes in our operations, we'll start with a percent and we want to see that represented as a fraction, maybe so that we can put it into an equation, maybe so that we can show it in a different way. But that's a useful thing to be able to do as well. Let's also look at converting percents into decimals. So that's kind of what we just saw here. So we've got, if we start with 65%, that's again the same as writing 65 divided by 100. So to do that, just drop that percentage sign, divide that number by 100. And then if you were to put 65 over 100 into your calculator, you get 0.65. You could also, this is a kind of speedier shortcut trick. Basically what you can do is just move that decimal over to the left 2 places, because you're starting with this whole number, 65%, and you want to show it as a fraction. So you should, and you're dividing it by 100, and each of these little decimal places is basically like we call it a tens place. And I'm not going to get too deep into this. This is like starting to go into the weeds of math. But just know, if you want to go from a percent to a decimal, you can just move that decimal that is invisible here in front of the 65% over 2 spots. And then you're left with 0.65 as your decimal, which is the same as 65%. And converting decimals into percents, it's kind of similar, just go in the opposite direction. So you're multiplying that number by 100 instead of dividing, and you're moving that decimal to the right 2 places. So if you start with a fraction of 0.65, you want to see that represented as a percent. You go 0.65 times 100. If you put that in your calculator, you'll get 65. And then you can just slap that percentage sign on and you're done. Or if you want to go the shortcut route, you're starting with that decimal. You can, because you're multiplying by 100, you get to just move that decimal point over 2 places. So that puts the decimal to the left, or sorry, to the right of the 65, and now we have a whole number of 65%. Just messing around with things here, but this is a really something that you'll probably do pretty commonly if you don't already. and definitely an important part of the exam because a lot of times math problems will give you a fraction or a percent or a decimal and want you to give the answer in a percent, or maybe the equation calls for one of those things over the other. So it's important to be able to shift around between all of them. So let's do a little practice. We're going to practice changing between percents and decimals. So go ahead and grab that pen and paper again. Or if you don't have that, talk it through with your neighbors. Look at start with the percents. We've got 3%, 0.05, so on. Those first four are changing percents to decimals, and then the bottom four are changing decimals to percents. And I'll give you all, let's see, about 2 minutes to go ahead and practice that.
Yeah.
So remember, if you're going from percents to decimals, that you're starting with a bigger number and you're going to end with a smaller number. So if you're starting with a whole number, in most cases, and then you're going to end with a fraction. It's part of the whole. Okay. Let's see how we did. So changing the percents into decimals, we're going to be, remember that we're starting with a percent, which is also the same thing as saying, like, for example, 3% is the same as saying 3 divided by 100. Because 100 is cent. It's another way of looking at it. So 3%, we could just plug into our calculators if we wanted to go that route. We could go 3 divided by 100. And that's going to give us 0.03 for that one. If we go to this 25%, let's try it with the decimal moving over strategy. So, 25% is the same as 25.0. So there's a little invisible 0.0 over there. And so we're just going to take that little decimal point and plop it over 2 places to the left. And that gives us 0.25 for that one. And then for 0.05, we could do that again. So we could take that little decimal. We already see it right there. And we're just going to scoot it over 1 place, 2 places. And then that leaves us with these 3 zeros in front of the 5. So it's 0.0000005. Lost count of my zeros. Okay, and then if we look at 135%, this one's kind of interesting, right? So rather than being a portion of 100, it's 100 plus a little bit, right? So if we did 135 divided by 135% divided by 100, we're going to get 1.35 as our decimal for that one. So it's one plus a little more. Okay, so then if we look at changing the decimals into percents, we're starting with a decimal, we want to show it as a percent. Then we're going to multiply by 100. So 10.5 times 100 is going to give us 1050%. That's how we would show that one. If we wanted to do this next one to the right, 0.01, then we're going to, let's try it with the decimal hopping over method. We're going to take that little decimal that we see and move it 2 spaces to the right. And so then we have 1.0, which is just 1, right? So that's 1%. 0.36, same deal. Let's take that little decimal percent and plop it over 2 spaces. We have 36.0, that's 36%. And then for that last one, you know, maybe you wanna try the method where you multiply. You could go 0.6263 times 100. Plop that into your calculator. You're going to get 26.3, and then you want to show that little percentage sign there. So that's all that is. Make sure that if you're moving from decimals to percents that you add in that percent sign, because otherwise, if you don't have that there, then you're kind of missing an important piece of information and it's not really correct, right? Because 0.01 doesn't equal 1, it equals 1%. So make sure that you are adding those percentage signs so that you can keep track of them in your equations. And the same with the percents to decimals, make sure that you're dropping the percent sign if you're converting it to a fraction. Are there any questions on that one? On the percents and decimals?
More question.
Any questions?
No, we're good.
Okay, great. Okay, let's also look at rounding. So this is a big, another really important concept for, especially if you're taking tests, like standardized tests. So like the ones that, like the ABC is, your answers are gonna come in a certain kind of number. And so often you'll notice that if we're working with decimals, sometimes you end up with a decimal that's like really, really long and you see it in your calculator and it's like 11.560612, whatever. How do you take that big long number and then turn it into a number that in a way that to show it as it's going to appear on the test? You don't necessarily write out that big old number every time, right? Sometimes you're like, oh, well, it's pretty close to 11.5, so we're just going to say that. Or it's pretty close to 12, so we're going to say that. So that's just what rounding is. So let's look at an example of that. Here we've got a temperature of a digester that operates in the mesophilic range, and it's measured at 37 degrees Celsius. So what is that temperature in degrees Fahrenheit? So what this story problem is asking you to do is find the temperature in degrees Fahrenheit. So just convert basically this degrees Celsius to degrees Fahrenheit. That's a pretty common one since we use Fahrenheit often in the US and territories, and Celsius is really common in Europe. So we kind of got to be able to move between both of them. So this equation is in your ABC formula sheet. So you'll be able to look that up if you need it. But in this case, we can look at that. We can go, okay, here's our equation that we're starting with on our formula sheet. Degrees Fahrenheit equals Celsius times 1.8 plus 32. So what we're going to do is take what we know and what the story problem is giving us and plug it into this equation. So they give us one number and it's 37 degrees Celsius. So degrees Fahrenheit is our variable that we're trying to solve for. It's our X or what have you. And we can plug in 37 for the degrees Celsius. And then we have a perfect little equation that we can just plug into our calculator. Just make sure that you're doing the PEMDAS order of operations. We're going to do that multiplication first before we do the addition. So we'll do 37 times 1.8, and then that's going to be 66.6, and then we'll add 32 to that, and that gives us an answer of 98.6 degrees Fahrenheit. But wait, the answer that is given, we have our options on the left-hand side here, none of those are 98.6. But the thing is that all of those answers are rounded to this whole number. So it's like there's no fractions here. But this number 98.6 is pretty close to one of those numbers. So how would we round it? Basically, there's just like little rules about rounding. You round up to the next number or decimal place if the last digit is between 5 and 9, or the digit of the place you're trying to round to is between 5 and 9, and you round down if the last digit is between 1 and 4. And it's the last digit, or it could be just the decimal place that you're trying to round to. So if you have a big long number and you're like, I just want the first number after that decimal place, then that's the one that you're gonna use to reference whether you're going up or down on that last number. So in this case, we have 98.6. That last digit is between 5 and 9, so we're going to round up, and that will round up to 99. And so that would be the answer that we would circle on our test. Okay, that's a pretty important one. You'll see that come up a lot, especially as you do your calculations. And then let's talk a little bit about units. So units basically just measure. They kind of show what the number is representing. So, in that last equation, we had our units were degrees Celsius. That was what we were given. And then degrees Fahrenheit was what we were trying to get. And so that just shows us what that number means to us. And it's pretty important to keep track of those units as you go through your equations, because otherwise you're left with numbers that you don't really know where they go or what they mean. What are you measuring? So when we're doing applied math, which is what you all are doing as wastewater operators, you're doing applied math. So you need to keep track of what each number means, and that you do that by tracking with units. So units come in different types. For temperature, you're probably going to see that degrees Fahrenheit, degrees Celsius. There's also sometimes K, which stands for Kelvin. We see that's a little more rare, but that shows up in some of the more advanced equations. We've got distance and length, which we usually measure in inches, in feet, in meters, and miles, or kilometers. So if you see those units in a problem, that means that you're trying to find a distance or a length of something. If you see inches squared, feet squared, meters squared, all of that is area. And we'll get really, really in depth into that in the next math class. We're going to go over areas and volumes and those calculations. But all you need to know for now is that if you see that little 2 inches squared, feet squared in the unit, that usually means that that's an area that you're calculating or that you have. And volume, really similar, except it's cubed. Because you're going length times width times height. You're taking a number and multiplying it 3 times so that you end up with feet squared, meters squared. You can also see gallons sometimes, or liters, or acre feet. That all means volume. Mass, you might see pounds, grams, kilograms, and tons. And then rates. So rate kind of signifies an amount over time. So in this case, we might have cubic feet per second. That's a common way to measure water flow. Gallons per minute, another popular one. Just really quick here, kind of maybe you can plop it into the chat. Rate measurements are a unit, right? And what are we dividing? We are dividing that unit, so volume or distance, by what variable or dimension to get a rate? What do you think? Anybody? You can also shout it out, those of you who are in the class and in the room and can't put it in the chat. Yeah, sweet, nice job. Yeah, it's time. So it's a unit divided by time. And that's always going to be rate. So that's a good one to keep track of too, because that's a super common one that you're going to see. Okay. So as I kind of mentioned this earlier too, but we have two different systems. We use two different systems of measurement in the US and I think in the territories as well. And most people have to have some concept of both of those systems. So we've got the metric system, we've got the imperial system. And the metric system is kind of nice because everything makes a lot of logical sense, I would say. So, we start, our base is like a meter. And then if we're talking about like a portion of that meter, a hundredth of that meter is going to be centimeters, and centa means 100, and milli means 1,000. So if you see millimeter, it's 1,000th of a meter. So having some understanding of the metric system is pretty important. Just as you go through those problems, you might see something in milligrams or milliliters, but maybe for a certain equation you need it in liters. But just remember that all of these conversions you can do because you have you know how much a milliliter, how much of a liter a milliliter is, right? And we don't use all of these. Some of these are less common, and we don't generally use them in our day-to-day lives. But all of the ones that you see here that are not crossed out are really common ones. So those are good to know. Again, conversion factors, this is kind of similar. So if you're looking at an acre, that is a certain number of feet, right? If you're looking at an acre foot, that means a certain number of gallons. And all of these conversion factors are on your ABC formula sheet. So you can still use that as a reference, but it's good to be familiar with all of these and also their abbreviations, like what they mean, because that's going to come in handy when you're solving equations, and you've got unknown variables in there. It's helpful to know that 1 feet of water, if you're looking at 0.433 psi, that means pounds per square inch. That's a pressure measurement. So we'll get more into that in later classes, but just keep that in the back of your mind. Those are in your formula sheet. And when you're doing conversions from one unit to another, it's really good to have those conversion factors because they kind of give you a little edge in solving those equations. So yeah, again, ABC formula sheet has those abbreviations written out, and the conversion factors for them, super helpful. Make sure that you're familiar with them and using them on your exam. So how would you use conversion factors? You're basically like multiplying or dividing your measurement by that conversion factor. So this is just going to be like a kind of quick intro to conversions. We'll get more into that in later classes, and as you kind of go along. But just really quick and basic. What you're really doing with a conversion is turning the conversion factor into a fraction and then multiplying it by 1. So you're just trying to get your trying to like mess around with your different units so that you can solve for one of your units or the other. It's kind of another form of algebra. So in this example, we've got one example is 3.79 liters. So we're just turning that into a fraction, multiplying it by 1. Let's look at kind of it's one thing to explain it, and it's another thing to kind of see it in practice. So let me show you what that looks like in practice. And remember that if you're multiplying something by 1, that you're not changing its quantity, but you can change the units through that process. So an example of unit conversion, your sodium hypochlorite tank holds 40 gallons, but the store sells it by the liter. How many liters of sodium hypochlorite do you need to fill up your 40-gallon tank? Okay. So what this equation is, or this question is really asking for is just how many liters is in 40 gallons, right? So we need to represent that 40 gallons as liters. And we can do that by looking at our conversion factors. So we know that 1 gallon is equal to 3.79 liters. So we want to take that 40 gallons, multiply it by 3.79 divided by 1, And then what happens is that these 2 gallons will cancel each other out. So if you have, what you have on the left side here is basically 40 over 1. And then the gallons cancel out because you've got multiple, you've got a whole number here and you're dividing it by that same number, by that same unit. And then you're left with about 150 liters if you multiply 40 times 3.79. So I like to do this. It's going to get a little complicated. So I like to do it using this, it's like a little grid method. So I'm going to put 40 gallons over 1. And then on the other side of this grid, I have 3.79 liters over 1 gallon. And that's my conversion factor, right? 1 gallon is equal to 3.79 liters. So when I do this, you'll notice that I have a gallon on the top and a gallon on the bottom, and that's what I want because I want to get rid of those gallons so that I can see what the liters, how many liters I have. So I can, if I set it up this way, I'm going to cancel those gallons out, and then I'm just going to multiply across the top of the chart here. I'm going to go 40 times 3.79 liters, and that's going to also give me about 150 liters. And that's going to be what I would put for my answer. And it's really important in this is where I was, when I was saying it's really important to track your units. Make sure that you're keeping track of your units through the whole equation. Keep those liters attached to the numbers that they belong to, and then you can just solve within that. So again, this is really fast. I just want to give you all a chance to practice this. We'll practice it more. But let's look at this for figuring out sorry, how many gallons your clarifier can hold. So the whole problem written out, you're trying to figure out the volume of your clarifier. You measure it with your tape measure. You determine that it holds 46 cubic feet of water. Okay, so how many gallons does your clarifier hold? Well, all we're trying to do here is go from cubic feet to gallons, right? So we're converting from cubic feet to gallons. And 1 cubic foot, 1 foot to the third, we know if we look at our formula sheet equals 7.48 gallons. So let's look at that. If we take this equation and we put it into our little grid here, we're going to have 46 cubic feet over 1. And then on the right side, we're going to have 7.48 gallons and 1 cubic foot on the bottom, right? Because 7.48 gallons are in 1 cubic foot. And then we're starting out with this 46 cubic feet. So if we put it in this grid, we have cubic feet on the top and cubic feet on the bottom, which is what we need in order to cancel them out. Cancel out those 2 units, we divided by them. And now we're just left with this multiplication across the top of the equation. So we have 46 times 7.48 gallons. And that is going to, if we type that into our calculator, that's going to leave us with 344 gallons. Okay. So that's really just a quick intro, and we're out of time. I have another kind of more complicated equation at the end of this presentation. So if you want to do it by yourself, these slides will be available to you on that website of the slide that I showed earlier on our program website, and you're welcome to go in and do that. We're also in a couple of weeks doing another math class, so hoping to see you all there for that one. Just skipping through this last big one. We're at time here. I don't have time to take questions. This was a lot to pack into an hour, but please reach out to me. The email here, spepper@unm.edu. I want to answer any questions that you guys have. I know it was really fast, and math is kind of complicated. So just let me know if there's anything that you want clarification on or more practice with, and I'd be happy to help out. Just a reminder too that the next webinar in this series is going to be also a math class, and it's going to be on area, volume, and pressure. So we'll start taking those concepts that we built today, the foundations, and use them to move into a more applied realm of area, volume, pressure. So we're excited to see you all there. Also, I have a few minutes to stay later if anybody wants to stick around and ask questions. I'll just keep my video on and my sound on and I'll be here. If you have to bounce, that's totally fine and we'll see you. Thanks, everybody. If you have any questions, feel free to stick around.
Won't be the answer to it's gonna be the closest, not like.
They round it to.
Andrew, could you go ahead and stop the recording as well for me?
No.
Sweet.